Hi, I'm Patrick from Ratterman Manufacturing. One of the questions I'm often asked is about cryogenic transfer hoses. Within a fill plant, cryogenic transfer hoses are used in numerous areas. You have the transfer to liquid containers, to dewars, and to tube trailers. It's very important. The question that I get asked often is, we have a hose, we use it in the plant, and we used it yesterday over in the tube trailer area, and it seems like it's leaking. This is a common problem, and here's why. Hoses, cryogenic hoses, are different than your standard pigtails used in a fill plant. Cryogenic hoses use a corrugated inner core, and this is corrugated stainless steel. When you have this as your inner core, you have zero permeation. This is a great hose for transferring liquid and gas at lower pressure levels. These hoses are typically anywhere from 400 to 1500 psi maximum working pressure on your standard liquid transfer hose. But what about tube trailer applications? If you were to take this hose and use it in a tube trailer application, it would work okay at first. But as your flow rate increases and it exceeds a certain threshold, which is 150 feet per second, what happens is it establishes a resonant frequency inside the crown of the corrugation. That's the part that's curved. And keep in mind, the corrugation is metal that's bent. And so at the very top of that bend, it's very thin. It's probably at its thinnest point. That's where it's going to crack. So it's important that you don't exceed a certain flow rate with standard cryogenic hoses. What we did as an industry to combat this is basically we keep the stainless steel inner core, but we insert a Teflon liner. And that liner gives us a smooth bore. And basically, that smooth bore allows us to put through higher flow rates without any issues. So what you'll find is the tube trailer hose is quite different in that it has a Teflon liner inside of it, and instead of 2 layers of stainless steel, it's got 4 layers of stainless steel for 4,000 psi. The way to increase the pressure carrying capacity in a hose is to add an additional layer of stainless steel braid. This has 4. You go to 6,000, it takes it up to 6 layers, and it goes on and on. But essentially, what you're looking at here is a great example of a cryogenic transfer hose. You've got the all stainless inner core, which is corrugated. It's corrugated so you could bend it without damaging it. In the old days, everything was rigid on metal, on the hoses. And with rigid hoses, the only bad thing about them is they're always one bend away from cracking, and they will crack. So this is what the modern day flexible cryogenic hose looks like. You've got the corrugated inner core with layers of stainless steel braid, and right here is your armor casing. A lot of people ask, why do I need the armor casing? Well, not only does it keep your hose cleaner, keeps debris, dirt, and dust off of it, the biggest purpose of this is you cannot bend this beyond the hose's bend radius. So when you do take a hose and bend it beyond the bend radius, you kink it. And when you kink a hose, that is the area where it's going to blow when the right amount of pressure hits it. So the point being, when you show somebody a hose and you explain to them the non-permeation, the stainless steel inner core with the Teflon liner. You explain why the different layers of stainless braid and then the armor casing. It pretty much shows the customer that there is true value in all those things. And you can have a happy customer that has a product that works well for them for many years. Thank you.